This evening we shall talk about sets and operations on sets. When we say a set is a well-defined collection of objects. A well-defined collection of objects. What are these objects? These objects refers to the members in the set, the members, the components, or the things that make up the set, When we look in nature, almost everything occurs in groups. Example, we have humans being in groups, we have whites, we have blacks. In animals, we have a different sets of breeds of animals. As such, set is in the natural occurrence of events. For the sake of group theory, we can also say that a set is a group of well-defined objects for the sake of understanding. Now, let's talk about the operations on sets. When we say operations on sets, we mean what can we do to extract more information from the groupings that we will be talking about under sets. Under sets, there are only three operations that can be performed. They are intersection, meaning element that belongs to all the sets under consideration, whether set A, set B, or C. We have union. When we combine all the elements together, we get the union. They are union sets. We have complements, elements that belong to the set under consideration. When we talk about the complement, we mean elements that belongs to the universal set but do not belong to the set under consideration. Example, when we say the complement of A, we mean the elements that's not found in that set but are found in the universal set, which when perform the operation of union on, will give us the universal set, meaning it will make that set turn into a universal set. Hence, it will make it complete. It will complement it to become the universal set. Hence, every set and its complement will give you the universal set. Now, we shall then consider set notation. When we say set notation, it simply means set representation. How do we represent sets? We represent sets with capital letters of the alphabet. The members, or the elements, or the components in the sets are then put into brackets, specifically curly brackets. The curly bracket is also shown below in the note. We are considering ways of describing sets. As everything can be described, sets can also be described. There are three ways of describing sets. These are listing its members, that is, example, if A is the set of counting numbers less than 3, then we know that A is made up of 1, 2. With respect to that, we have used the listing method of describing sets. We also have the stating of the property of the set method, or using a description of a property of the set under consideration. That is, we shall put into brackets the description in words. Set A is equal to counting numbers less than, let's say, 3, or prime numbers less than 12. And with that, we would then be known to list its members. We also have the third method, known as the set builder notation. And it reads as X is such that, the colon stand there for such that, X is such that let's say 1 is less than x and x is less than 12. 1 is less than x and x is less than 12, meaning x is greater than 1 and x is less than 12. So by looking at these three methods or ways of describing sets, we can use any one of them to show how a set is, either by listing its members, by giving a word description in terms of its property, or by using the set builder notation, as shown in the notes below. Ways of describing sets. Types of sets. Basically, there are several types of sets, but for easy learning, we can take it as there are basically two types of sets: finite sets and infinite sets. Finite sets is a set whose last member or element is known. The opposite being the infinite set is a set whose last member is unknown. So also take note, the number of elements in a set is known as the set's cardinality. It's known as the set's cardinality. The number of elements in a set is called the cardinality of the set. The cardinality of the set. And the number of members or elements in a set is denoted by n. So when you look at set A under consideration, A is equal to 12, is equal to A is equal to 2, 4, 6, 8. The number of elements in A is given by n bracket A equals bracket close 4, meaning the members in the set, when we count them, are 1, 2, 3, 4. We continue with the types of sets. We have the null sets. The null set is also known as the empty set, and is represented by an empty curly bracket, or by the symbol as shown near the curly bracket. We also have a unit set, meaning it's made up of only one element or member. The element or the member of a set is represented by E. So with this, we can see that set Q has a member or an element of 2. Universal set. It refers to the set, as the name implies, universal, the set of all the elements or objects under consideration. Its symbol is shown in the notes below. We have a equivalent set. Sets are said to be equivalent when they have the same number of elements. Please take note, the same number of elements. The same number, meaning if it's made up of 4 elements, the other one is also 4 elements. If 3 elements, the other one is also 3 elements, but not the same kind, the same number of elements. So looking at the notes below, we have 2, 3, 5 for set A, and we have set B to be 11, 12, 13 for set B. Since their cardinality is the same, we say they are equivalent. Since their cardinality is the same, meaning they have the same number of elements, we say they are equivalent. Equal sets. Sets are said to be equal, implying they have the same kind of element. That is, they have the same cardinality. As well as the same kind of element. Example: set A equals 2, 3, 5. Set B equals 5, 2, 3. Have you seen that the elements are the same? Hence, they are equal, the same kind. Under our number system, we have sets of numbers. So when we say natural numbers, we say natural numbers, we refer to the set of natural numbers. And the set of natural numbers are also known as the counting numbers. and they are represented by the symbol n. The set of whole numbers. The set of whole numbers. They are the counting numbers with 0 included. They are the counting numbers or the natural number with 0 included, meaning it starts from 0, 1, 2, 3 up to infinity. So it's an infinite set. We also have the set of odd numbers. The set of odd numbers. They are numbers or the set of numbers that are not exactly divisible by 2. We have the set of even numbers, which are the opposite of the set of odd numbers. They are numbers that are exactly divisible by 2. You have the set of prime numbers or factors. They are numbers that have only 2 factors. Their factors are 1 and the number under consideration itself. We have 2, 3, 5, 7, 11, 13 as such, and it's an infinite set too. We have the multiples of numbers. When we say the multiples of numbers, you can only get the multiples of numbers by multiplying the numbers by the counting numbers, starting from 1. So when you say the multiples of 2, we mean 2 by 1, 2 by 2, 2 by 3, in that order. The set of integers. When we say the set of integers, we simply means the set of positive and negative whole numbers. The set of positive and negative whole numbers. Meaning, we have the